Pre-qualified WPS. We're going to talk about AWS D1.1 specifically and the pre-qualified WPS and how it generally works and fits into the welding world. My name is Gary Pace. I'm a PE and a CWI out of Katy, Texas.
A WPS. What is a WPS? Well, a WPS is basically the recipe. We've done our PQR and we've come up with a recipe. We've already cooked the cookies once and everything came out good, and we know that if we follow that process, we're going to get good cookies every time. So with a WPS, we take what we did on the PQR and we make a recipe that the welders are going to use. It's just a work process. It's instructions. It's a recipe that tells the guy cooking everything, making the cookies, how many eggs, how much flour, how much chocolate chips, whatever. It tells him, hey, I'm going to weld this kind of carbon steel to this kind of stainless steel. I'm going to use this filler material. I'm going to use this shielding gas. I'm going to use this backing gas. This much preheat, or this is going to be my heat input. You're telling that welder everything that needs to go into that document to deposit sound weld metal into that joint. So basically a WPS is just a recipe. Welding Procedure Specification. The Welding Procedure Specification is a required document for all code welding. Your customer either directly or indirectly specifies to what code your company must qualify. The WPS outlines all of the parameters required to perform your welding operation. In short, the WPS is the recipe for welding operations. It describes the welding process or processes used, the base materials used, the joint design and geometry, gases, flow rates, welding position, and includes all of the process conditions and variables. Each code has a recommended format, but you don't have to follow the recommended format. If you want to come up with your own format, that is totally cool. You can run with that. But there are recommended formats, and it kind of gives you a good starting point. Recommended, not required. The American Welding Society supplies a number of codes. The following is a list of some of them. Structural welding steel, AWS D1.1. AWS D1.2 is structural welding aluminum. AWS 1.3 is structural welding sheet steel. This is the same as, not the same as, it's steel, but it is structural steel, sheet steel that's under 1/8 of an inch, I think. You'd need to read the specifications, but I'm pretty sure that it's under 1/8 of an inch. AWS D1.1 covers everything above, and then D1.3 covers everything below. D1.4 is structural welding of reinforcing steel, rebar. D1.5 is the bridge welding code. D1.6 is structural welding code for stainless steel. And D9.1 is sheet metal welding code. Sheet metal welding code covers all kinds of different sheet metals. And this is different than D1.3 because that's structural welding of sheet steel. So you need to keep your codes in mind, and if you have any questions, look at the front page of a welding code and it'll tell you the scope. D1.1 and its scope will tell you this is for structural steel. Don't use this code for welding titanium to stainless steel or whatever. I know I pulled a bizarre combination, but I pulled it out just to illustrate the point. Structural welding code is structural steel, buildings and things like that. It's not for boilers, piping, pressure vessels. And a lot of people have this misconception that D1.1 is a catch-all. Early on in my career, I had a design engineer wanting hydraulic cylinders designed to AWS D1.1, and I tried to explain to him, and for the life of me, I could not explain to him that this is not the code for that. And then finally, somebody came up with the idea that our hydraulic cylinders would meet the all the applicable portions of D1.1, and then everybody was happy. But you need to realize that there's different welding codes, and the American Welding Society has this list as well as others for welding codes that they write.
Okay, the American Welding Society, the AWS, if you've had anything to do with welding and you're on the North American continent, you've pretty much heard of the American Welding Society, and generally worldwide. They publish numerous documents covering welding and welding-related activities. The AWS produces codes, specifications, recommended practices, classifications, methods, guides related to welding. General subject areas are definitions, symbols, filler metals, qualification and testing, welding processes, welding applications, and safety. If it has to do with welding in the North American continent, the American Welding Society probably has something to do with it in one way, shape, or form. So they're the de facto, welding experts on the North American continent and worldwide. Them and a couple outfits in Europe are probably the leading technical subject matter experts for codes, standards, etc. An overview of D1.1, the structural welding code. So this is the contents of AWS D1.1. It's about a 500-page document with all the annexes and commentary and index and just everything. It's a self-contained construction code, design code. It covers structural welding. So what we want to talk about is Clause 3, Prequalification of WPSs. Clause 3 is one of the major, cornerstones of this welding code, because you've got qualification and pre-qualification. So I've already talked a little bit about qualification in another. Well, actually, I talked about it for about an hour in another video. So now I'm going to talk about pre-qualification of WPSs, and specifically AWS D1.1. So what does pre-qualification mean? Pre-qualified welding procedures are permitted by some industry standards and codes. Under this allowance, the employer or fabricator prepares in writing a welding procedure conforming to the specific requirements of that governing code for materials, joint design, welding process techniques, etc. for the application. AWS D1.1 Structural Welding Code, Steel, has joint details and welding processes which are classified as pre-qualified. Therefore, the preparation of the WPS for this application is much simpler process than qualified by testing. So it's basically telling us, and I think I'll probably repeat this 52 times during this module or this video, but you're allowed for some codes like D1.1, the materials you're using are, they have a set list of materials that are pretty common, structural materials that have been used over the last 60 or 70 years, and if you weld them with a certain welding process and you follow the rules, then you don't have to qualify a procedure. You don't have to run a coupon. You don't have to send it out to the lab for testing. You just say, this is what I'm going to do. You follow these rules. You make sure you follow those rules, and you're pre-qualified.
Pre-qualified WPS. A pre-qualified WPS doesn't require a supporting PQR. I'll probably have to do a whole nother slideshow presentation on pre-qualified WPSs, but I'll just cover it here on this slide real quick. A pre-qualified welding procedure specification uses known variables that have a long history of making sound welds and require no testing. A written procedure is required for all pre-qualified WPSs. So what's this telling us? It's telling us that there are codes like AWS D1.1 structural steel, which is carbon steel. They have a list of materials that are your garden variety, plain Jane, carbon structural steels, that if you weld them within the boundaries of what AWS D1.1 has said you should weld them with, they've kind of got this little recipe checklist that you go through, and if you follow it and you follow all their rules for welding that metal to that metal with that filler metal, and you follow their rules, you're not going to mess it up. It's been done for 80 years using 7018 to weld A36, that not everybody on the planet needs to requalify this. If you just follow these rules and you write down what you're going to do, you got to have it written down. You can't just go out there and weld it and say, well, this is pre-qualified. I already looked it up. No, you need to have it written down so the welders have a WPS to follow. You just don't have a PQR to back it up. So I'll make another video and we'll get crazy about pre-qualified WPSs.
Preparation of a pre-qualified WPS. Okay, so when you're going to do this pre-qualified WPS, it's like doing a regular WPS and PQR. You're going to review the job requirements. You're going to select a suitable welding process. How big is this weld going to be? Do we need to use submerged arc, or can we do it with shielded metal arc? Where are we going with this? What does our shop do well? What do I have welders that I can qualify to? Where is this part going to be produced? Is it going to be produced in the field? Is it a field weld, a shop weld? These are all things you need to know, and then make decisions on. Then you're going to fill in. I'd do a rough draft, the suggested format, whatever format you're going to do. I'd do a rough draft of the WPS and put it together that way. And then I'd ensure that all the welding variables are covered, make a first run at it, and then ensure all the welding variables are covered, and then come back and write a final WPS. And then, you're probably going to have to submit it to somebody, some kind of reviewing agency, or, the client or an engineer. Your final, you're going to review it, and then you're going to use it in production. So that's how you put together a pre-qualified WPS. Here's an example of an AWS D1.1 pre-qualified weld procedure. You can see this is the standard form. You can get it out of the AWS D1.1. You can use another format. You're not stuck with this one. This is just kind of a general run-of-the-mill procedure. And you can see that you can use it either as pre-qualified, qualified by testing, or as a PQR. So you just check the boxes on, what type of document you're going to use. This can be a procedure qualification record. You check the procedure qualification record up top. Or it can be a WPS, and in that case you check whether it's pre-qualified or qualified by testing. But if this is like I said, here is an example of a pre-qualified procedure, we don't need to do testing. We're just going to go through AWS D1.1, the pre-qualified section, which is clause 3. Used to be sections, but then it got confused with ASME, the American Society of Mechanical Engineers. They call their stuff by sections. So the American Welding Society calls theirs clauses, which is like a chapter. But anyways, I digress. With a pre-qualified procedure, you just go through clause 3, and you pick out your weld metal, you pick out your base metal, you pick out your positions, your shielding gas, whatever is appropriate for those pre-qualified weld processes, like shielded metal arc welding. So if everything falls within the parameters of clause 3, you have yourself a pre-qualified weld procedure. But this is what the form looks like. Welding procedures. A welding procedure specification of WPS is a document that provides essential instructions on how to successfully complete a weld. It's the recipe card that a welder works off of. Voltage, amperage, whatever essential variables that guy needs to complete that weld. It's like a recipe that tells the welder what to use and how to do it. Base materials, filler metal, shielding gas type, flow rates, weld joint designs, welding parameters, preheat, special instructions, whatever. It should all be on that welding procedure specification. And we've got two different kinds of welding procedure specifications. We've got qualified and pre-qualified. Today we're going to talk, in this module, we're going to talk about pre-qualified. Overview of AWS D1.1 Structural Welding Code. Okay, we're going to talk about Clause 3, Prequalification of WPSS. Okay, there's limitations and you still have to qualify welders. You know, no matter what happens, you have to qualify the welders. There's no pre-qualification of welders. Okay, so when we get into welding processes, AWS D1.1 only has 4 welding processes that you can use. You can use shielded metal arc welding, which is stick welding, submerged arc welding, flux core arc welding, and gas metal arc welding. The gas metal arc welding, you can't use short circuit. If you're going to use short circuiting, you got to qualify it. Flux core and GMAW must use constant voltage power supplies. I touch base on that in a minute. There are code approved processes: electro slag welding, electro gas welding, gas metal arc welding, short circuit, and gas tungsten arc welding. You can use these in accordance with AWS D1.1. You just can't pre-qualify them. You're done with clause 3 and you got to go to clause 4 is where you need to go. A few years back, just on a side note, AWS went from calling these the chapters, I'll call them. They went from calling them sections to clauses because the sections started getting confused with ASME Section 9, ASME Section 3, ASME Section 4. So anyways, we're talking about clauses. So the clauses of Clause 3 is pre-qualification. It's basically the chapter that covers pre-qualified WPSs. You don't go digging around in Clause 2 or Clause 7 for pre-qualified weld procedures. You need to stay in Clause 3. That's the important thing. And you need to use one of these 4 welding processes: stick shielded metal arc, submerged arc, flux core, or gas metal arc welding. GMAW-S is prohibited for pre-qualified WPSs. Gas metal arc welding S, also known as short arc, is great for welding on thin gauge materials. This welding process is not suitable for structural steels as the low voltages and amperages result in low heat input, which leads to fusion problems when welding on heavy materials. Cold lap or lack of fusion is a defect where the weld metal does not fuse to the base metal. You can have incomplete fusion, lack of fusion. I've seen people run short arc, gas metal arc welding short arc test coupons, and it's the most beautiful test coupon you've ever seen. And you go and put it in the bend tester, and it'll crack right along the fusion line. I mean, it is a straight line. It is amazing. It just snaps. I wish it happened 20 some years ago when I was testing welders at a previous employer. But if I'd had a digital camera, I'd have taken some pictures. But this was prior to digital camera, and I didn't think to get a little, a little Kodak disposable and take some pictures of some of these things for a later date that old Gary might appreciate and work into a PowerPoint presentation. But so that's what you got to worry about with gas metal arc welding, and that's why it's prohibited. You can't use it. You can still use it in AWS D1.1. You just can't use it as a pre-qualified. You can run your weld procedure with this and send it off to the lab, and if it passes and you get good bends and good tensils and whatever other testing needs to be done for your situation, you can go with it. But it just is not able to be used with pre-qualified. And I'm sure that the code committees that put the code committee that put this together has probably a million examples of why this shouldn't be done. But that's my theory, is why it shouldn't be done. And, well, not my theory, but generally that's, the prevailing opinion of why it shouldn't be done. And I'm sure I don't have access to it, but I'm sure the code committee has a million different reasons and code cases and situations to back up their decision. And I think I don't argue with it. I'm just saying there's people a lot smarter than me that made this decision years and years ago. So trying to give you my commentary on it. Pre-qualification of WPSs. Pre-qualification of WPSs welding procedure specifications, shall be defined as exempt from the WPS qualification testing required in Clause 4. All pre-qualified WPSs shall be written. In order for a WPS to be pre-qualified, conformance with all of the applicable requirements of Clause 3 shall be required. WPSs that do not conform to the requirements of Clause 3 may be qualified by tests in conformance with Clause 4. For convenience, Annex Q lists provisions to be included in a pre-qualified WPS and which should be addressed in the fabricator's or contractor's welding program. So what this is telling us is that here's the recipe that we need to follow to pre-qualify a welding procedure. And if you can't check every box and get complete compliance with Clause 3, you got to go to Clause 4, which is the qualification. You're going to have to do a test plate, do some bend tests, and whatever else needs to be done. And Annex Q, there's a little checklist. We'll touch base on that here in a bit. Annex Q lists what you need to include in a pre-qualified WPS. Pre-qualified WPSs are welding procedure specifications that are between common structural steels that have been done so many times in the past that if you use the welding processes with the filler metals and base metals listed in Table 3.1 and 3.2, you don't need to do a formal qualification test, but you must write it down in a formal WPS. You don't need to do a test coupon, send it to the lab, any of that. You just need to write down what you're going to do. Key, you need to write it down. Okay, before I start this slide, I'm going to just get a little philosophical for a moment. So if you're going to be a guy writing or a person writing a lot of WPSs, to me the way is to get good at this is you got to get some lists, and you got to get used to working off lists. And the codes have a lot of lists, and you need to know where to find these little checklists. So Annex P is one of the places where you can find this little checklist. So if you go in there and you take a look-see at Annex P, it gives you the list of everything that you need to check off when you're doing a pre-qualified WPS. So it's going to tell you, is it one of the pre-qualified processes? I'm using electroslag welding. Nope, it's not a pre-qualified process. Can't use electroslag welding. Oh, we're using shielded metal arc welding. Yes. Are my base metal and filler metal combinations two that I can use? Yes. Did I get the preheat and interpass temperature requirements? Yes. So you can go down limitations of WPS variables, general WPS requirements, pre-qualified WPS variables on table 3.7. These are all really big ones. Base metal for weld tabs and spacers, heat input control. These are the big ones. I didn't cover everything on the list because the list is probably about 3 times bigger than this, and some of it is kind of minutia. But, this is a pretty good place to start in regards to putting together a WPS. And if you're going to, like I said, from a philosophical standpoint, you need to get used to working off checklists and checking your work and going over it, and then maybe have somebody else take a look at it before you send it on to have it reviewed by a reviewing party like an engineer or a client or some kind of body like that. 3.2, welding processes. This is out of AWS D1.1 Clause 3. 3.2.1, pre-qualified processes. SMAW, SAW, GMAW, except for GMAW short circuiting, and FCAW WPSs which conform to all the provisions of Clause 3 shall be deemed as pre-qualified and are therefore approved for use without performing WPS qualification for the process. For WPS pre-qualification, conformance with all of the applicable provisions of Clause 3 shall be required. So you got to use this process, these processes, one of the 4 I've got pictured here, and I just read through, and you got to meet everything else, all the applicable provisions of Clause 3. If you don't, you got to go to Clause 4 and qualify it. Processes for pre-qualification, acceptable. shielded metal arc welding, submerged arc welding, flux core, and gas metal arc welding, but only in spray and globular transfer. The unacceptable processes, you can still use them with AWS D1.1, but you can't pre-qualify the procedure. You're going to need a PQR as electroslag welding, electrogas welding, gas metal arc welding short circuit. That means you're running on the low voltage side of things, 19 or 20 volts or less. Gas tungsten arc welding, and which is TIG welding, you're going to have to run that. You're going to have to run a PQR for that. There's no pre-qualification. Those you need, this kind of breaks it down. I know I've mentioned this, covered this information about 3 times, but we'll just keep doing it that way, right? Cover it and recover it, reteach it. 3.3. Only base metals and filler metals listed in tables 3.1 and 3.2 may be used in pre-qualified WPSs. The base metal filler metal strength relationship below shall be used in conjunction with tables 3.1 and 3.2 to determine whether or not matching or undermatching filler metals are required. So the way this is written in the code, that table off to the left, it's below this, the paragraphs. So you're going to use the tables 3.1 and 3.2 to figure out which filler metal you're going to use, and then you're going to figure out if it's matching or undermatching. Any steel to itself, then you use a matching filler metal. Any steel in one group to any steel in another group, you're going to use any filler metal listed for either strength group. So there's some things you need to figure out. I don't know everybody's situation or what you're trying to weld, but this is one of the areas that you use to figure out what you're going to do if you're welding filler materials or base metals together that aren't matched up. If you're welding filler base metals from a group 1 to a group 2 or a group 2 to a group 3 or whatever you got going on, this will help you figure out what you need to do as far as getting your filler metal strength straightened out, and then finding which filler metal is proper to use and if it even fits in with this code or this clause. Maybe if the filler metal you want to use for certain base metals doesn't fit in with what tables 3.1 and 3.2, you might have to just qualify the procedure and go to clause 4. Table 3.1. This is from clause 3. They kind of changed it up here the last time they rewrote the AWS D1.1. So the tables have kind of changed a little bit. But anyways, the basics of 3.1 are, this is the approved base metals that are pre-qualified for WPSs. If you're using some kind of Chinese steel or some kind of steel from Guatemala or Istanbul or wherever, and it doesn't have paperwork that it says it's one of the materials listed on this list, you can't use it. Even though chemically it might match up, if you don't have paperwork that says it's ASTM A573 or ASTM A1011SS grade 30 or whatever, you can't use it. You got to go qualify it. You can still use that steel, but it just can't be used as a pre-qualified steel. So something to keep in mind. I've had people try and, when I was reviewing weld procedures, I spent a couple years in a cube in the Midwest reviewing weld procedures for an engineering outfit, big engineering outfit. Anyways, we were doing some work in China and in Vietnam and down that way, but there was a lot of Chinese steel fabricators, and they'd try and send in a pre-qualified WPS with some Chinese steel, and it's like, no, it could hypothetically be the same, but unless you got paperwork that says it's ASTM A36 or A5, 24 or 573, you can't use it. Go do a qualification. So just something to think about. if you're writing them, you need to realize this table exists, and if you're reviewing these procedures, you need to realize that this table exists. So table 3.1 and 3.2 used to kind of be put together. So table 3.2, it just tells you the filler metals for matching strengths. So group 1, if you're going to use a group 1 steel, these are the filler materials that you can use. I didn't capture all of the table because it's a couple 3 pages long. But anyways, the materials are listed here, what you can use, what you can't for pre-qualified weld procedures. Importance of preheat. Paragraph 3.5 of AWS D1.1 is explicit about minimum preheat and interpass temperature requirements. Table 3.3 shall be used to determine the minimum preheat and interpass temperatures for steels listed in the code. So you have to follow these. If you have a thick material, a couple inches thick, and you're welding it and you're in a cold climate in Minnesota or North Dakota or Chicago, you're going to want to preheat it to make sure that you have sound weld metal deposited in the weld joint. So ultra important that you preheat in cold climates and thick materials, and the code realizes this. That's why they have a table that lays it out for you. You don't have to do much legwork. You just need to look it up and then list it on your pre-qualified WPS. Get off on a little tangent here. The importance of preheat. Reason to use preheat are it drives off excessive surface moisture, hydrogen. It can slow down the cooling rate in both the weld and the base metal, thereby lowering hardenability, and it will make the weldment less likely to crack. It allows more time at higher temperatures for hydrogen diffusion. Less hydrogen in the weld and base metal lowers the tendency to crack. So those little hydrogen atoms that could be swimming around in your weld joint or in the base metal, they swim a little faster and get themselves free of the base metal and the filler or the weld metal if it's a warmer material. That hydrogen diffuses through the material a lot quicker at 400 degrees than it does at 30 degrees Fahrenheit. It also reduces the differential temperature, so residual stresses are less. It's just a little nicer on the metal, helps keep the residual stresses to a minimum. Table 3.6, pre-qualified WPS requirements. So you want to go to table 3.6, and you can see I've kind of outlined some things. So you see that I've outlined shielded metal arc welding in the red there, and then the variables in the green on that side. You're going to need to go through and put in the maximum electrode diameter that you can use in your pre-qualified WPS. So you can see there, for a fillet weld in the flat position, you can use 5/16 inch piece of shielded metal arc welding filler material as the max. In a groove, you can use 1/4 inch, which is pretty big too. 5/16 is a pretty good sized piece of filler metal. But you can't use that in the overhead. The largest piece of filler material for shielded metal arc welding you can use in the overhead position for both fillets and grooves is 3/16. So you need to address everything for your welding process. If you go down under shielded or submerged arc welding, I got a little purple box under there, maximum root pass thickness. You're not going to run shielded metal or submerged arc welding in the vertical overhead position. So some of these are just left blank if it's not possible to do it with that process. So vertical and overhead for submerged arc welding isn't going to happen. But if your process that you're using has a variable listed and it's in a position that you're going to use it in, you need to address it. Table 3.7 has the WPS variables that you need to address. So I outlined shielded metal arc welding. So you got to use the welding process. If I'm going to switch welding processes, I got to get another procedure. A change in welding positions, I got to get another procedure. Or I at least need to address it. A change in metal group numbers, a change in base metal, preheat categories. These are all things you need to address on your pre-qualified WPS. But a lot of them don't, like number 11 down there towards the bottom, a change in the mode of transfer. There is no mode of transfer in shielded metal arc welding. But in gas metal arc welding, if I'm going to change from spray to short circuiting, I got to change my, I got to write a new WPS. And if I'm going to go to short arc, I got to use a different, I got to qualify the procedure. So I can't use pre-qualified. Just a lot of different things. There, I got a little box there in purple on number 6. If you follow that over, there's a purple box. Change in the electrode flux classification. Well, that doesn't apply to gas metal arc welding because you're not going to use a flux. That would be a submerged arc welding variable. So there's a lot of things that you don't need to address. And when you're writing a pre-qualified WPS, you don't have to check every box because there's a lot of things on that sheet, you know, their form, their recommended form, that don't apply to every welding process. So don't get in the idea in your head that you got to check every box. You just got to go to this table and check what, you know, make sure that you've addressed everything. Okay, so on table 3.7, there's some variable limitations. So if you have your procedure written for a certain voltage, I don't know, call it 27 volts. Well, you can, if you're going to increase it by 15% or decrease it by 15%, you got to write a new procedure. A change in the travel speed for gas metal arc welding, you know, a change in 25% increase or decrease, you got to address it. A change in the nominal composition of shielding gas. So if your weld procedure is written with, you know, I don't know, 85% argon, 25% CO2, and you're good with that, then, and you change it to a 90% argon, 10% CO2, you've got to rewrite your weld procedure. Change in the post-weld heat treat. A lot of times you don't use that in structural, but if you change the, if you add post-weld heat treat to a weld or you remove post-weld heat treatment from the weld, then you need to address it and rewrite your procedure. Here's another little caveat involved with the AWS D1.1 and pre-qualified weld procedures. You need to use a constant voltage power supply. The flux core, arc welding, and gas metal arc welding power sources, you got to have a, you know, a constant voltage power supply. You can't have a constant current. I know there's a lot of situations where you can run flux core and gas metal arc welding with a constant current machine, but to do it pre-qualified, you have to use a constant voltage power supply. You don't have any other options. So, something to keep in mind. Joint design. When you're doing a pre-qualified weld procedure, you got to follow the joint design. So there's a whole bunch of different, there's pages and pages of different examples of pre-qualified joints and partial penetration joints. So the complete joint penetration CJP groove weld is a groove weld that extends completely through the thickness of components joined. The primary purpose for the use of a CJP groove weld is to transmit the full load carrying capacity of the structural components they join. The partial joint penetration PJP groove weld is a groove weld that does not extend completely through the thickness of the components joined. So it might not be as critical. I'm not a structural engineer. I have a cursory knowledge of, you know, the joint designs and when you'd use a CJP and a PJP, but when they are called out, you have to follow what's called out on the drawing. And in doing so, many times you can use a pre-qualified procedure if those configurations that are called out on a drawing fit up with what your the pre-qualified weld procedure that you've put together. This one goes hand in hand with the previous slide. CJP is a complete joint penetration weld. You can see that there's 100% of the base material thickness has been welded up. So complete joint penetration. You can see the bottom joint is a PJP. It's an example of a PJP, partial joint penetration weld. There's a lot of different configurations you can go with complete joint penetration and partial joint penetration. But this is just to give you an idea of the terminology in case you had never been exposed to it. So when you're writing your pre-qualified weld procedure, there's about, I want to say 30 or 40 pages of nothing but pre-qualified joints, examples, and it tells you which processes you can use them with, and just a whole bunch of information, base metal thicknesses, groove preparations, the whole 9 yards, so that your detailer, can utilize these when they're detailing the job, and you can have these listed on your procedures. So this is what they look like. Generally, I've just done a groove weld or maybe partial penetration weld, something simple. I haven't dabbled into too much of the exotic joint configurations when I've done pre-qualified. But it depends on what kind of work you're doing and what you've got going on. So, but this is an example. If you dig through clause 3, there's just pages and pages and pages of these examples of pre-qualified weld joints. And this is an example of a pre-qualified complete joint penetration weld joint. Here's another example. These are all, some are in millimeters and some are in imperial units, inches. And so you got to watch what you're looking at too. Like I said, there's some that are in millimeters for, people that are working in situations that use the metric system, and the exact same stuff is in the imperial. So just depends on what you're working with. That is something to keep in mind when you're taking a look at these pre-qualified joint examples. The main advantage of using a pre-qualified weld procedure is you don't have to take the time and the money to run a test coupon and do a PQR and send it off to the lab and do all that work. You're going to have to write up some documentation for your WPS, but you don't have to qualify a procedure. You don't have to take all that time. So it could save you, potentially, a few $1,000 that in time, effort, and whatnot to run a test coupon, do a PQR, send it out to the lab, and then write up a WPS. So one advantage, no test coupon. No mechanical testing. Like I said, you don't have a test coupon, you don't have mechanical testing. And not that this is, a break the bank kind of outlay, but, if you're a small shop and whatnot, and you don't have the money and you just need a procedure for, welding something with 70-18 or 60-10 or whatever falls within the, the materials that you're going to weld, you don't have to do the mechanical testing at the lab. So saves you some time and money. So, summary of our pre-qualified WPS module or episode or whatever we're calling this. So we talked about what is a WPS. It's the recipe that welders use to make a weld and deposit sound weld metal into the joint that's on the drawings or the plans. We talked about codes and standards, a little bit. Some codes and standards allow you to use a pre-qualified WPS, and we pretty much talked about AWS D1.1 being the one that we're worried about. There's no test coupons, no mechanical testing and no PQR required for a pre-qualified WPS. This is the advantage of using a pre-qualified WPS. We talked about preparation of a WPS. You do have to write a WPS. Just because it's pre-qualified doesn't mean you can scratch it on a napkin and say, oh, well, 7018 in this material is pre-qualified, we don't need a WPS. No, you need a WPS. You actually have to write a WPS. And it's got to be available to the welders because it is the recipe. It's the recipe they're using to make the pizzas. So you actually have to have it written down. That is a key point. And the code makes sure and emphasizes that. AWS D1.1 does. So hopefully this has been helpful to you. You got questions, comments, you know where to track me down. Hopefully this pre-qualified weld procedure conversation, a little bit of AWS D1.1's kind of helped clear up what's going on in clause 3 of AWS D1.1. So anyways, everybody take care. Thanks for watching, and if you have something else you'd like me to touch base on welding wise, lob me an email or leave a message and I'll see if it fits in with something I have the expertise to cover or is something that'll be of interest to people. All right, thanks. Take care. GP out.